So the purpose of this video is for a couple of things. So number one, I want to go ahead and review all the concepts that we've talked about so far in past videos relating to derivatives. And also, I want to go ahead and just do a bunch of problems. This video can be used in a couple of ways because I want this video to work for you and to help you use your study time efficiently. So here, there's 3 ways you can use this video. So number one, you can watch me do them. I'm going to do them thoroughly so you can watch each step and like sort of get into my thought process and hopefully learn from that. Or number two, you can go look at the problem, then you can just pause the video, then try it out yourself, and then you can go ahead see what the answer is. And then if you got it wrong, then you can go ahead and try doing the problem again, or you can just watch my explanation. I'd highly recommend you watch my explanation at least for a few of them, just so that you make sure you sort of see these relevant ideas. So number 3, this table of contents here, I'm gonna have links to each of these types of problems in the video. So you can click on the type of problem you really want to see, then you can go ahead and just focus on those problems. Again, I want this to be as efficient for you as possible, so it's important that you use it as such. Okay, so that's how this is gonna work. Now, if you're watching this from a mobile device, then I have links to these sections in the description. So that said, let's get started. Alright, so these problems are going to be dealing with the definition of the derivative. So, however, they are slightly trickier problems than you might be used to, just because you have to think a little bit more. Now, the work involved is actually a whole lot less than your typical plug-in f of x plus h and then sort of solve using algebra, but again, you have to just be you have to think a little bit more. So I'm going to walk through the logic of this problem, and then we can really work through it. So this is really just me reminding you a little bit of what the definition of the derivative really is, and to just showing you a different type of problem. All right, so what has happened in this particular type of problem is we have already plugged in a value of x. So we have taken this expression, we've already plugged in some value into it. Okay, so what this has really become is, if we were to go ahead and just translate this, what this would be is the following. So the limit as h approaches 0 of f of c plus h minus f of c all over h. So that's what this expression essentially translates to. Now, what we need to do here is we need to go ahead and from this we need to find f of x. So really we're kind of reverse engineering things here. So we need to find f of x from this expression here, and then once we've got that, we can easily find f prime of x using the power rule, and then we can just go ahead and evaluate this at the point c. And by the way, c is basically the value of x. So once we've got our f prime of x, once we found f of x, then we can find f prime of x and then plug in c, and we've got our derivative. Okay, evaluated at the point, which is exactly what this problem wants. Okay, so the first step is to go ahead and identify what these are. So first thing to notice is always keep an eye on this thing on the outside. That is like 9 out of 10 times, that is going to be your f of c. Okay, now why? That's just because it's a constant. And remember, when you plug in an x value into the function, you get out a y value that's more often than not a real number. So therefore, f of c is obviously just going to be some kind of number, and that number is on the outside. It's subtracted from the rest of this expression, and therefore it makes perfect sense that would be our f of c. Okay, so for now let's consider that our f of c. Now what about this guy over here? What does that mean? So if that is our f of c, then this is just going to be f of c plus h, right? So that's going to be our f of c plus h. So now, how do we sort of take this a step back and go from f of c plus h to f of x plus h. And then taking that another step back, we want to go to find f of x, and f of x is our real golden goose here. Okay? Now again, let's just keep in mind what we do when we plug in x plus h. When you plug in x plus h, so let's take an arbitrary function here. Let's take the function y f of x equals 6x. If I said plug in x plus h, what you would do is, so if I said find f of x plus h, you would do the following. You'd say 6, and then instead of x, you'd say x plus h, right? So essentially what you're doing is wherever you have an x term, we're plugging in x plus h. So let's keep that in mind, and let's take a look at this again. So we see a 1 plus h here. So that essentially means that that term right there represents x plus h, right? Because basically you have an h in there. So this is a really important statement right there. When we say this is x plus h, this allows us to do two things. So number one, we now know what f of x is, okay, because we can simplify this out. And number two, we can now find out what x is, okay? So let's go ahead and do those out in turn. So 5 minus 3 times x plus h. If that is what f of x plus h is, then it only takes another step to figure out that the function really is 5 minus 3x. Okay? And now if 1 plus x equals x plus h, then simple algebra will tell you that x equals 1. Okay? So now we've gone ahead and we've identified the function and the x value. So really, what this question is asking for is it's asking us to evaluate the derivative of 5 minus 3x at x equals 1. Okay, that's just what it's asking us. Now this is a very, very simple problem, and now we can just go ahead and finish that in a matter of seconds. So d dx of 5 minus 3x is basically negative 3, and now evaluated at x equals 1, it doesn't really matter because the answer is still going to be negative 3. And because it's a constant function, therefore it's going to have the same slope everywhere. Okay, so that's how we do this problem, and I hope I helped you sort of walk through the logic. And now just to practice, let's go ahead and try the second one. So I'd recommend you try this on your own just to make sure you understood what we really talked about over here. But in any case, I'm going to go over it now. So again, the first step is the same. We're going to try to identify what f of x is, and then we're going to try to identify what x is. Okay, so again, let's just look at it through these lenses. So we have an f of x plus c plus h minus f of c, and again, this thing's on the outside, this is our f of c, right? Now again, let's look at this. This is our x plus h term, which means that our x is going to be, that means this is going to be, so to find the function, we just replace this with x. Okay, so we're just going to replace that with x, and what we're left with is that f of x is x cubed, and if you solve this out, you're left that, so f of x is x cubed, and x is negative 2. And why is it negative 2, not positive 2? That this makes sense because you have a plus 8 here, where it really should be a minus f of x. You have a plus 8, okay? So that makes sense. Now we just have to go ahead and do the following problem, which is the derivative of x cubed evaluated at negative 2, or x equals negative 2, and this is going to be 3x squared evaluated at negative 2. This time this would be 3 negative 2 squared, which is simply 3 times 4 equals 12. So there you are. Those are your answers. And these problems, I know they're a little bit complicating, but I hope we sort of exercise your brain a little bit and sort of help you solidify the definition of the derivative. And again, these are the sorts of problems that you're going to see if you do the AP test or stuff like that. They really want you to think. All right, so these problems are just a basic test of our power rule and a little bit of algebra that we'll need to do to simplify some of these to make them solvable. So first case, very, very straightforward power rule. So dy dx equals, so power rule, we bring the 2 down first. So we have a 2 here. Then we subtract 1 over there. So this would be 2x to the first, but I'm just going to leave it as 2x minus 10x to the first. We can say that. So we bring down the 1, so that just leaves 10. You subtract 1, so you're left with an x to the 0th power, which is also just 1, so I'm not going to write it out here. And for the 100, if you remember, this is simply 100x to the 0. And therefore, the moment I multiply everything by 0, this entire term just gets wiped out. So I'm just left with my answer is dy dx equals 2x minus 10. Now, y equals 2x to the third in parentheses. So this is a little bit more complicating. We're going to need to do a little bit of work before we solve this. We can't do it like it is right now because we lack something called the chain rule, which allows us to do stuff like this. So what we're going to need to do is we're just going to need to go ahead and FOIL this out first. So this is essentially the same thing as 2 cubed times x cubed, which is basically 8x cubed. Now again, this is just a simple case of power rule. So this is dy dx would be equal to, again, we multiply 3 times 8, which is 24. Then we subtract 1, which is going to be x squared. Okay? Plain and simple. Last but not least, we have this problem here. Now, you may be really thrown off by the 1 plus x squared here, because we haven't learned how to do this explicitly. But what we can do with this problem, with this particular expression, is we can rewrite this as x to the negative 2, okay? And that is just really helpful because it just gives us an x with an exponent instead of a sort of quotient like this. And let's go ahead and just write the whole expression out, which would be y equals x squared plus x to the negative 2, right? Now you can just simply use the power rule here, but you have to be a little bit more careful, and we'll see why. So dy dx equals, again, bring the 2 down, so this would be 2x. Again, 2 minus 1 is just 1, so I'm not going to write the 1. We're going to take this negative 2 and bring it down here. Okay, so this is going to be minus 2, and obviously we have an x. Now we're going to subtract 1. So this is going to be, it's not going to be 1, but it's going to be negative 3. Okay, so 2x minus 2x to the negative 3. All right, so that would be our answer. Now, most people are fine if you just leave it like that, but if you wanted to take it a little step further, you could write that this is the same thing as 2x minus 2 over x cubed. Both are equally valid answers, and you should get the same credit for both of them. All right, so this problem is just going to go ahead and take it a little bit further in terms of concepts. So the work is not very difficult in this problem. We're just going to have to sort of really go back and look at what a derivative actually gives us. And this is something we've spent like whole videos talking about. So find the equation of the tangent line to the function of f of x at the point 0, 0. So we've been given a function, we've been given a point, and we're being asked to calculate the tangent, the equation of the tangent line. So you'll see problems like this all the time on AP tests. So it's really important that you know how to do stuff like this. So f of x equals x to the 4th minus 3x squared plus 16x. So we have this function over here. Now, first thing you should think of is whenever you see tangent line, you're thinking derivative. Okay, tangent line, you're thinking derivative. But it says equation of the tangent line, not slope. Well, what is the equation of a line? So the equation of a line is something in the form of y equals mx plus b. Right? That's the general form of a line. Now, what two things do you need to get such an equation? So you're going to need two things here to get a good line equation, the equation of a line. So one thing you're going to need is a slope, and the other thing you're going to need is a point, right? So you need a slope and you need a point. So the point is just given to us. We know it's 0, 0. We also know this function goes to the point 0, 0, so we're good there. What about the slope though? The slope, remember, the slope of the tangent line is something that comes through derivative. Please forgive my handwriting. So the slope of the tangent line is something we get through the derivative, right? So therefore, we're going to find the derivative of this. So let's just go ahead and write out our steps here. So we're going to find the derivative, and we're going to use the derivative to find the slope of the tangent line. We're going to find the slope of the tangent line, and then we're going to use that information to create the equation of a line. So again, this is just really going back to reminding us what the derivative really tells us. It's telling us the slope of the tangent line at any x value. It's a function that gives you the slope of the tangent line at any x value of the function, okay? So again, let's find f prime of x. F prime of x is very simply just basic power rule now. So bring the 4, subtract 1. So this is going to be 4x to the third minus times 3 minus 1, 9x squared plus, so this is again 16x to the first, bring that down, subtract 1, you're left with just 16. So that right there is your derivative, but that's not our final answer. What we're going to need to do now is we're going to need to find f prime of 0. F prime of 0 is 4 0 cubed minus 9 0 squared plus 16, which is simply 16. Okay, so this is our slope, or m10. So we have our slope, we have our point. Now you could plug these into the form of y equals mx plus b, but you could also use what's called point slope form, which is slightly easier in my opinion. So point slope form is the following. It's y equals m x minus x1 plus y1. This is basically what it is. Instead of solving for b by plugging the point in and then doing all kinds of like little algebra, you could go ahead and just plug in stuff directly into this, and then you're done. And again, this is certified, accepted on the AP exam, so you're good to go. This is not just a dirty trick I'm teaching you. So if we plug in everything, we're left with y equals 16, which is our slope, x minus 0 plus 0. And if you just simplify that out a bit, you're left with y equals 16x. That is our final answer. All right, so again, we found the slope of the tangent line using the derivative. We took this point, and then we just plugged them all into point slope form. All right, so in this set of problems, we're just going to be going over some of the rules we learned in our derivative table last time. So these are the things you should really have these memorized. But again, instead of just rote memorization, it's better just to do a bunch of problems. And as you'll see, as we do more and more of these problems, they'll sort of just become second nature. Okay, so let's go ahead and get this done. So y equals 3 sine of x plus inverse tangent of x. So again, let's just go ahead and get started with this. So dy dx equals 3. Again, this is because of the rule about the constants, means I can pull out a constant out of any derivative expression, is the derivative of 3 times the derivative of sine of x. So what is the derivative of sine of x again? Well, that is cosine of x, if you remember right? The derivative of sine of x is cosine of x. That's an easy one to remember, honestly. Now, what about inverse tangent of x? Derivative of inverse tangent of x is a little bit more complicating, but it's something you should have down anyways. This would be 1 over 1 plus x squared. And it's really important that you have these down, because especially as you approach integration, all of this is going to be even more important. So they're going to be really important for derivatives, but they're going to be just as important for integrals, because actually with integrals, you're just doing derivatives backwards, so you're using the exact same rules. Okay, so let's just flesh this all out. So 3 times the derivative of sine of x, which is just going to be cosine of x, plus 1 over 1 plus x squared. So that's our answer. And again, this is more of a either you know it or you don't problem. So if you know what the derivative of sine of x is, then you know the derivative of inverse tangent is, you're good to go. And this is a very simple problem. Pardon me, this should be e to the t times natural log of t. It's a bit of a typo there. So f of t equals 5e to the t minus 10 ln of t. So again, this is basically just basically to test if you've memorized the rules. So again, this is going to be f prime of t is going to be 5, and the derivative of e to the t is, if you remember, e to the t, right? Because ddx of e to the x is e to the x, so 5e to the t minus the derivative of ln of x is basically 1 over x, so minus 10 over x. Once again, this is a very either you know or you don't problem. This problem is where things get slightly more interesting, all right? So 14 tangent x cosine of x plus 10 cosecant of x. Now, for tangent times cosine, this is not something we know how to do right now with our basic rules, right? Just because we don't know what the product, we don't know about what's called the product rule, which enables us to take the derivatives of products. So it's not possible for us to do this with our typical derivative rules, or we can't do this as it is. But what we can do is we can go ahead and rewrite the tangent as 14. And again, what is tangent? Let's think about that for a second. Tangent is basically sine of x over cosine of x, right? And then we're multiplying that by cosine of x and plus 10 cosecant of x, right? Now, the cosines are just going to cancel, so we're left with 14 sine of x plus 10 cosecant of x. And then that's just an easy derivative. So f prime of x is, so we know that from up here the derivative of sine is cosine. So 14 cosine of x. And the derivative of cosecant is actually going to be n. It's going to be negative cosecant of x cotangent of x, right? So this is just going to end up being a total of 14 cosine of x minus 10 cosecant x cotangent x. All right, so there you have it. That's what these derivatives are. All right, find the equation of the tangent line of the function f of x at the point pi over 2 comma 1. Again, this is the same thing that we did last time. We were given, so in this problem, again, it's another tangent line problem. So what we need to do is we need to go back in, we need to get a point, and we need to get a slope. And the specific slope is the slope of the tangent line. So again, this we find through a derivative, and this we basically just find. This is more often than not just going to be given to you. Okay, so let's go ahead and do that now. So f prime of x is going to be the derivative of cosine of x. It's a pretty easy one. Derivative of cosine of x is negative sine of x be careful of that one, negative sine of x. And the 1, it's just going to go to 0, so we can ignore that. So this is your derivative right here. Okay. Now, what do we do next? We need to go ahead and find the slope. So we're going to need to find f prime of pi over 2, which is going to be negative sine pi over 2, which is just going to be, if you just remember the unit circle, that's just going to be negative 1. Okay, that's our slope. We're still not done, so we need to go ahead and plug this all into our equation now. So we have pi over 2 and 1 as our x and y values, and then we have our slope. So now all we have to do is go ahead and plug these into our final equation. I'm going to use point slope form here, but please feel free to use y equals mx, the slope intercept form, if that suits you better. So let's just write out the point slope form. So this is going to be y equals m x minus x1 plus y1. So I'm just going to go ahead and plug in everything now. So this is going to be y equals negative 1 times x minus pi over 2 plus 1. And you can just leave this as is and you will be fine. Alright, so that's about it. Thank you so much for watching. I hope this video was helpful. I hope we could really go over some good concepts, and I hope this really helped you prepare for any test or quiz that you're doing, or just helped you solidify your understanding of calculus even further. Regardless, please do like this video if it helped you, share it with your friends, leave a comment, tell me how I'm doing. Any constructive feedback is always appreciated. And once again, thank you so much, and I hope to see you again in my channel soon. Take care.